Okay, so I'm going to go through this lesson where we're going to talk about limit properties. So sometimes we're going to need to consider limits symbolically, and we can be given combinations, compositions, and other modifications. And so there are some properties that we just need to learn. So the very first one is the constant rule. And so the constant rule states that the limit of a constant is that constant. So what this means is the limit as, say, x approaches any number. So in this case, we'll say x approaches 2 of 6. That is going to be 6, right? This is a horizontal line. And so because of that, if we're approaching a number on a horizontal line, it is going to be what that value of the horizontal line is. So the next one is the identity function, and that is the limit as x approaches c of x equals c. So what this is saying is the limit as x approaches, say, 2 of x, that's going to equal 2, right? And this makes sense because this is a line with a slope of 1, and so that's how we're getting that limit. The next one is the coefficient rule. And so this basically says if we're taking the limit of something and there's a coefficient out front, we can bring that coefficient out in front of the limit. And so what this means is, let's say we have the limit as x approaches 2 of 6x, that 6 is considered a coefficient. And so to make it easier to solve, we can bring it out front and take the limit as x approaches 2 of just x. Another property we're allowed to do is a sum or a difference. This basically means if we're taking the limit of two functions added or subtracted together, that is their limits added or subtracted together. So again, let's stick with that limit as x approaches 2 of, say, 3x minus 1. We can turn that into the limit as x approaches 2 of 3x minus the limit as x approaches 2 of 1. So we're allowed to kind of split those up. We also have the product rule, which means if we're taking the limit of a product, then the answer is the product of their limits. So this is saying if we're taking, say, the limit as x approaches 2 of 3x minus 4 times 2x plus 1, we can split that up and make that the limit as x approaches 2 of 3x minus 4 times the limit as x approaches 2 of 2x plus 1. And we can do something similar with division. Again, the limit of a quotient is the quotient of their limits, with one caveat, and that caveat is that the limit of that denominator can't equal 0. If it did, then that means we're dividing by 0, which we're not allowed to do. But we could say the limit as x approaches 2 of 3x over x squared, that would be the same thing as the limit as x approaches 2 of 3x over the limit as of x approaches 2 of x squared. So we're allowed to take that as a fraction. And then we have a couple of really important rules that we do need to know. So one of them is the power rule. And so the power rule says that if I'm taking the limit of something to a power, then I can find the limit of that something and raise it to a power. So for example, I could say, okay, if I'm trying to find the limit as x approaches 2 of x squared, I could instead find the limit as x approaches 2 of x and then square that entire thing. So I'm allowed to take it kind of on the outside. The other really big one is a composition of functions. And so this is saying the limit of f of g of x is equal to f of the limit of g of x. And so we do have to be really careful here. It's kind of hard to write this in a notation, but let's say if we did the limit as x approaches 2 of f of 2x, this would be the same thing as if we took the limit first and then plugged it into f. Okay, so that may be a little tricky. It'll make a little more sense when we do some examples. And then the last one is the root power, but the root power is actually really similar to the exponent the root rule is really similar to the power rule. So that's if we're taking the limit of a root of a function, we can take the root of the limit of the function. So this is basically saying if I have the limit as x approaches 2 of the square root of x, that's the same thing as the square root of the limit as x approaches 2 of x. So, but in order for this to work, that root does have to exist. So we have some sum and differences. We're just going to jump past that and get into some examples. And so the first one, again, it says use property of limits to find each of the following limits. So that means we have to rewrite it in order to get credit. So for this first one, it's a sum. So we want to split it into 2, the limit as x approaches 3 from the right of f of x plus the limit as x approaches 3 from the right of g of x. So looking at our graphs, we have f and g. So the limit as x approaches 3 from the right on f of x is going to be 6. And the limit as x approaches 3 from the right of g of x is going to be 8. And so that's going to equal 14. Okay, again, you have to write this step. Alrighty. Now, I'm going to do the next one in 2 different steps, but you can kind of do it in one. So our first step is going to be separating the difference there. So that would be the limit as x approaches 5 of 3 times f of x minus the limit as x approaches 5. My pen's not working. Come on. Oof, give her a sec. Okay. Minus the limit as x approaches 5 of 2 times g of x. Now, this is still not simplified enough. We want to simplify it all the way down until we're just working with a limit of g of x or a limit of f of x. So in order to do that, we need to take the coefficients out front. So we do 3 times the limit as x approaches 5 of f of x minus 2 times the limit as x approaches 5 of g of x. Now, if you can do that all in the same step to get to here, that's totally fine with me. So then we're going to say, okay, now we can go ahead and plug in because we're looking for the limit as x approaches 5 of f of x. So as we approach 5 here, we are approaching 2. So we'll plug in 2 for that. And then we also want to do minus 2 times the limit as x approaches 5 of g of x. So as x approaches 5 here, that is 4. So we're doing minus 2 times 4. So that's going to give us 6 minus 8. So the answer is negative 2. Alrighty. I'd like you to try the next one. So what you should get is a limit as x approaches negative 5 from the left of f of x minus the limit as x approaches negative 5 from the left of g of x. So as we approach negative 5 from the left in f of x, we are reaching 3. And as we approach negative 5 from the right on g of x, we are approaching 4. So we're doing 3 minus 4, so you should have gotten negative 1. Alrighty. So, again, the next one, if you can make the jump to that final step, that's totally fine. If not, we're just going to go piece by piece. So, again, here we'll first start by splitting it up into a numerator and a denominator. So we'll put the limit as x approaches negative 7 of 3 of f of x over the limit as x approaches negative 7 of g of x. But we're still not quite done because we do still need to take that coefficient out front of the limit. I know it's tedious, but we do need to do this. I need to be able to see your thinking, so you must include this stuff. So then we can go ahead and plug in because we have a limit for f of x and a limit for g of x all alone. So we'll do 3. And then we want to do, as we approach negative 7 for f of x, and that is 5. So 3 times 5, and we're dividing that by the limit as we approach negative 7 for g of x, and that is 3. So when we do that, we'll get 15 over 3, which will just end up being 5. Okay, so we do have to also pay attention to the order of our properties. So like for this next one, we have that 4 out front. So in this scenario, we should take the 4 in front of the limit first. So we want to take that 4 out front first, and then we can split up that multiplication and say 4 times the limit as x approaches 3 of f of x times the limit as x approaches 3 of g of x. And then we can go ahead and plug in. So we have 4. The limit as x approaches 3 of f of x is here. That's going to be 6. And as we approach 3 for g of x, we have a slight issue there. That does not exist, right? So we get 4 times 6, and then times does not exist, right? Which really isn't a thing. That just means that this entire limit does not exist. If a portion of it doesn't exist, then the whole thing does not exist. Alrighty. So the next one, we have something squared. So again, we're going to take that square on the outside of the limit. So this will become the limit as x approaches negative 3 of f of x. That entire value, we're going to square. So we look as f of x as we approach negative 3. That is going to be negative 6. So what we're really doing here is negative 6 squared, which will end up being a positive 36. Alrighty, this next one we have to split up quite a bit. First thing we should do is we should take that square root out front. So we can rewrite this as the square root of the limit as x approaches 4 of 8 times g of x. Okay, but then we also need to take that constant out front of that g of x. So we want to do the square root of 8 times the limit as x approaches 4 of g of x. So now we can substitute in for the limit as x approaches 4 of g of x. So we'll look at g of x. So as x approaches 4, our y value is approaching 5. So we'll plug in 5 there. And so we'll get the square root of 40, which we would want to simplify, and that's going to be 2 root 10. Alrighty, try h on your own. So when you do h, you should get that, again, our splitting up would look like this. And we do need to include this. And then we could just go straight ahead and plug in. So when we find the limit as x approaches negative 3 of f of x, we get negative 6. And for g of x, we actually don't have a limit there. So we'd get negative 6, but then we have plus something that does not exist, which that's going to make the whole thing be does not exist. Alrighty, I'd like you to try the next one. So again, what you should do is write it as 2 limits, the quotient of 2 limits, the limit as x approaches 6 of f of x over the limit as x approaches 6 of g of x. So as we approach 6 for f of x, we get 0. And as we approach 6 for g of x, we're getting 5. So this is going to give us 0 over 5. And that's actually totally fine. We're allowed to have 0 over 5. But 0 over 5 would just become 0. What wouldn't be allowed is if this was flipped, because then the denominator would be 0, and that's not permitted. All right, and then our last one. So again, our limit properties tells us, okay, this is a composition. So if I'm taking the limit as x approaches negative 2 of f of g of x, then I can do f of the limit as x approaches negative 2 of g of x. So we're going to start from the inside working outwards. So we're going to find the limit as x approaches negative 2 of g of x. So as we approach negative 2 of g of x, we're approaching negative 3. So that means what I'm looking for is f of negative 3. So once I do that, I'm not looking for a limit anymore. I'm looking for f of negative 3. And f of negative 3 is going to be negative 6. So my answer here would be negative 6. Alrighty. Next page. So we can also do this when we're given specific pieces of information. However, we have to simplify this down so that I have something identical to this that I can plug back in. So, again, as you get better, you can start doing this all in one step. So the first thing I would do is make sure that we're taking that square root on the outside. And we're doing 3 of h of x minus 2 of g of x inside of that limit. So I am going to go ahead and do the coefficients and the subtraction at the same time. So again, still all underneath the radical. We'd be doing 3 times the limit as x approaches c of h of x minus 2 times the limit as x approaches c of g of x. So I am okay if you make this jump. But again, we needed this to happen because we're trying to get things that are identical like this so that I can substitute in. So here we have just the regular limit as x approaches c of g of x and the regular limit as x approaches c of h of x. So that means I can substitute those values in. So I can say, okay, this is going to be the square root of 3, and then in for that value, I'm going to put what it is, which is 4, minus 2, and then for that value, I'm going to put negative 2. So that's going to give me the square root of 12 plus 4, which is the square root of 16. So my answer is just going to be 4. Right. So again, I'm going to make a jump here because I know that I can. So I'm going to go ahead and jump to the statement I need before I can plug in. So I would say the limit as x approaches c of f of x times, I'm going to take that coefficient out front, 5 times the limit as x approaches c of g of x. Again, I have those identical pieces now, right? I have that identical g of x, so I'll substitute something in for that, and the identical limit for f of x, so I'll substitute in for that. So I know that that limit of f of x is 3, I know that I have 5, and I know that g of x is negative 2. So then I can go ahead and multiply those two together. 3 times 5 is 15, times negative 2 is going to be negative 30. Alrighty. Again, we can do this in pieces, or if you're really good, you can do it all in one step. I am going to take that 2 on the outside of the limit first. So I'd say the limit as x approaches c of 7 minus g of x. This whole thing, this whole limit is going to be squared. Excuse me. And then I can go ahead and separate this even further, right? I'm going to take the limit as x approaches c of 7 minus the limit as x approaches c of g of x. And again, that whole value, once I get it, is going to be squared. So you may be saying, wait, but we don't have the limit as x approaches c of 7. And you're right, we don't, but that's going back to that constant rule, where if I'm taking the limit of a constant, it is that constant. So that means in this scenario, the limit as x approaches c of 7 is just going to be 7. So I'm going to have 7. And again, I have that identical match of the limit as x approaches c of g of x. And so in for that, I'm going to plug in negative 2. And I'm going to square the whole thing. So when I do that, I'm going to get 9 squared. So my answer is going to be 81. Alrighty. This next one, I'm going to jump to the simplified version. So what we would do is this would be 2 times the limit as x approaches c of f of x plus 3 times the limit as x approaches c of h of x over the limit as x approaches c of h of x minus the limit of x as x approaches c of g of x. And if you can make that jump, then you're welcome to. If you need to do it in other steps, that's okay as well. So again, we have that nice g of x, we have that nice h of x, nice and pretty all on its own. Good to go there. And that f of x. So we'll go ahead and substitute in. So we're going to say 2 times f of x, which is 3, plus 3 times the value for that limit of h of x, which is 4, over 4 minus negative 2. So 2 times 3 is 6. 6, so this is 6 plus 12 over 6. So it'll be 18 over 6. And so my answer is 3. I know that you may be able to jump to that from the beginning, but we're just not allowed to do that. We have to write out that property step. Alrighty, I'd like you to try the next one on your own. So what you should get when you do this is the limit as x approaches c of h of x times the limit as x approaches c of f of x plus the limit as x approaches c of 6. Okay, so the limit as x approaches c of h of x is 4. The limit as x approaches c of f of x, we should get 3. The limit as x approaches c of 6 is just 6. And so then we should be able to simplify. So we do 4 times 9, and we should have gotten 36. Now the last one is a little bit trickier, and that's because we have kind of a lot going on. So I am going to jump to the final answer. If you can't, again, take it step by step. So in that numerator, we're going to have our own limit for that, but it's also squared. And so we want to take our squared on the outside of that limit, and then in the denominator, we're going to have a limit for each of these pieces. So it should look like this. So then in the numerator, we'll substitute in for that limit as x approaches c of f of x, and that's going to be 3 squared. Again, the limit of a constant is that constant, and the limit as x approaches c of g of x is 2. So 3 squared is 9, oh, I'm sorry, negative 2. 3 squared is 9 over 6. That's going to simplify to 3/2. Alrighty, this one's a little tricky. So you can try to do this all in one, or you can do it piece by piece. It's kind of up to you. I'd like you to try it on your own, but we're going to go through it together. So first thing I would do is split it up by addition or subtraction. So we have 2 f of x times g of x minus the limit as x approaches c of the cube root of f of x plus the limit as x approaches c of 2 times g of x squared. Okay, then I would just go piece by piece. So we know that we can split this first one by multiplication, and we also know we can take that 2 out front. So that 2 is like in front of the f, but it doesn't really matter because it's all multiplication. So we're doing 2 times the limit as x approaches c of f of x, and we're multiplying by the limit as x approaches c of g of x. So that's our first piece. Okay, again, I took that coefficient out front, that 2, and the other pieces are the limits multiplied together. The next piece, we have the cube root of f of x, so I'm going to take that on the outside of the limit. So I'm going to do the cube root of this limit. And then that third piece, we have a coefficient of 2, and then we're also going to raise the whole limit to the second power. So we're going to do 2 out front, and then this whole limit. this entire thing squared. So now we can plug in, and this time we're plugging in with these numbers. So I'm going to do 2. The limit as x approaches c of f of x is 8. And I'm multiplying by negative 4. Then I'm subtracting the cube root of 8. And I'm adding 2 times negative 4 squared. So 2 times 8 times negative 4 is going to be negative 64. The cube root of 8 is 2, so minus 2. And then 4 squared is 16 times 2 is going to be 32. So the answer to this should be negative 34. All right. We just got one more page, yeah. Okay. So we want to find the limits of the following functions of compositions of functions. So again, what we're trying to find here is the limit as x approaches 2 of f of g of x. What this actually means is we're trying to find f of the limit as x approaches 2 of g of x, right? We're using that property to make it a little bit simpler. So we're going to start with finding the limit as x approaches 2 of g of x. So we're going to start with doing f, again, of the limit as x approaches 2 of g of x, which is negative 2x. So easiest way to get that limit is just by plugging in, right? The limit as x approaches 2, if I plug it into that function, I'm going to end up getting negative 4, okay, because I'm plugging in 2 for x. So what I'm really looking for is f of negative 4. So again, then we're no longer looking for a limit, and I can go ahead and plug it into this function. So I'm going to do negative 4 cubed minus negative 4 squared plus 4 times negative 4 minus 1. Negative 4 cubed is negative 64. Minus negative 4 squared, so minus 16. And then a minus another 16 and minus 1. And so when we do that, we should get a negative 97 as our answer. Okay, and we can kind of go the other direction as well. We can find the limit as x approaches 2 of g of f of x. So we would do g of the limit as x approaches 2 of f of x. Okay, that means we're going to go ahead and we need to find the limit as x approaches 2 of f of x first. So the way we find that is we go ahead and we plug it into f of x. So we say 2 cubed minus 2 squared plus 4 times 2 minus 1. So that's going to be 8 minus 4 plus 8 minus 1, which will give us 11. So once we find that, what we're really looking for is g of 11. And so we can plug in 11 into this function. So we'd say negative 2 times 11. So that's going to be negative 22. Now, these are not the same number, okay? So the limit as x approaches 2 of g of f of x is not the same as the limit as x approaches 2 of f of g of x. But we're essentially plugging into the inner function and then plugging into the outer function. We will talk about what happens when that limit isn't easily gotten by just plugging in, but not right now. So we're going to go ahead and use these graphs to find the following limits. So again, we're doing a composition. So we rewrite this as f of the limit as x approaches 3 of g of x. So we start with the inside. We want to do g as x approaches 3 of g of x. So as x approaches 3 of g of x, we're getting 1. So then what we're looking for there is f of 1. So then we find f of 1, and f of 1 is negative 2. And so that's going to be our answer. Okay, again, next one, we're taking g of the limit as x approaches negative 1 of f of x. So we go over to the f of x graph and we look at, okay, well, what is our y value as x approaches negative 1? So that's negative 6. So we're really looking for g of negative 6. And so that doesn't actually appear on our graph, but we see that this line has a slope of 2. So if we have the point negative 4, negative 3, we're going to have the point negative 5, negative 6. And then we'll have the point, I'm sorry, negative 5, sorry. And then we'll also have the point of negative 6, negative 7. So we do have to use our imagination there a little bit because we know that this line keeps going on and on and on. And so this is going to end up being negative 7. Okay. Again, we're going to do f of the limit as x approaches 1 of g of x. So the limit as x approaches 1 of g of x, we see here, oh, it is not the same from the left and from the right. So that limit does not exist. Again, if a portion of that limit doesn't exist, then the whole thing does not exist. Does not exist. And lastly, we're doing g of the limit as x approaches negative 3 of f of x. So we'll look at our graph. We're doing the limit as x approaches negative 3. So that is negative 6 again. And so again, we're finding g of negative 6, which is negative 7. Alrighty, good to go.